Okay, so let's start again. So the problem was just Chrome apparently had to be restarted. Sorry about that. So okay, let's look into transformation now. So we are going to apply map to the RDDX and get the RDDY. Okay, so visually, what's kind of happening is each element here gets mapped into Y. So you can also choose whether you want to preserve the partitioning or not. Okay. Here's our example. So we're going to take the Spark context, parallelize it, and basically pass the array of strings ABC, and that's going to be our first RDDX. Then we're going to map each element in the RDDX. I'm calling the element Z now, just to, because you can call it whatever. And I'm simply turning that element into a tuple with the element and the number 1, integer 1. Okay, so that's all. So now these are just transformations, so nothing's actually happened except that it remembers what you want to do. So now I'm going to do an action, which is this collect action. But at the end of the collect action, I'm going to append this dot make string method. Okay, so I get a nice printf like this instead of just one line at a time. So what I've done, I've taken the RDDX, which was strings B, A, and C. Remember, we put A, B, C, but it comes in as some other. Yeah. And then I'm going to just make them into ordered pairs, the integer 1. So this is the primitive for counting words. So now we know there's 1B, 1A, 1C. So let's now do the filter on this. That's again another transformation. So what's the mental picture? You have an RDDX, and then you apply the filter F to it. So you simply get things that you don't want, you just leave behind, right? Or the things that pass this Boolean filter, make it to the next RDD. So that's how a filter basically looks. So here I'm basically going to filter. So the closure here is going to be returning a Boolean. It will be true if the element n in the RDDX has remainder 1, right? And it's divided by 2. So if n is odd, I keep it. And that's exactly what I've done now. Took 1, 2, 3 and kept only the odd ones. So now let's perform the reduce action on the RDD. So here's the idea. So we're going to have some elements. We're going to aggregate all the elements of the RDD by applying any user-specified function pairwise to elements and the partial results that ensue from previous such operations. And the reduced values, it will return to the driver program. That's basically the idea. So I'm going to just add, reduce. See, and I like the syntax, or it's explicit because it's a mapping from 2 elements to one element. Right? In this addition reduce. This gives me my sum, and now I can make string and 10 plus 4 plus, sorry, 4 plus 3 plus 2 plus 1 is 10. Okay. Then we can transform an RDD by a flat map to another RDD. So how do you visualize a flat map? Here's your RDDX. But each element in the RDDX is now going to get turned into more than one element, right? It could be a line in a text file, has lots of words. So we take a line, an RDD of lines, and then turn them into RDD of words. That's a flat map operation. That's exactly how this looks. And you can also choose about preserving partitioning or not. And this kind of can matter depending on what you're going to do. So here's a simple flat map operation. So first I take the array 1, 2, 3, and then I'm just adding, taking the array and turning it into a tuple at the n and times 142. So, okay, so that's a flat map. So now we create a pair RDD. So this is an important beast. So, I have my immutable words, which is an RDD of this array of A's and B's, and then I collect it. So that should give me an array back. And here's all these repeating strings. Now what I'm going to do is take the words RDD and map each S to S comma 1, and then I'm going to collect just to see what's there. Okay, and please don't do this collect if you're looking at like all of Wikipedia. Right, so now I have A1, B1, and so on. Now we want to perform some transformations on the pair RDD. What do we want to do? So each element in the paired RDD is a key and a value pair. So I'm going to first do reduce by key, which is a transformation. And I'm going to do a sort by key, which is another transformation, and group by key. Okay. So how does this look like? Reduce by key takes a paired RDD. And so let's say the example here is the reduce operation is addition. Then this is kind of how you can think of it. So initially it's A1, B1, A1, blah, 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 like this. And so in this partition, it's going to apply addition, reduction. And since there's only one of A and one of B, it's going to just give me just one A and one B. And inside this partition, it'll do the same. Here, of course, there's two A's and two B's, so it'll do this. And here there's three A's and three B's. And then now, depending on if these partitions are in the same Java virtual machine, same node, or in different nodes with Ethernets and so on, whatever the case is, it gets like moved across the nodes. Okay. So typically there'll be lots of partitions in one machine. And depends on the case.
For those who are dealing with Hadoop, so all the row above is equivalent for combiners.
Yeah.
So they make some preliminary data transformation before shuffling over that.
Yeah. Yeah. So this is essentially what's going to happen. So now, things get combined and then they keep trickling up and finally reach the driver. So here's your word counts, reduced by key, and I'm taking an ordered pair V1, V2 and turning them into V1 plus V2. So if you pay attention to this, I only need to specify what is going to be happening to the values, key specifically, right? So that's why it's reduced by key. So I'm saying what should happen to the values. So I have 6 A's and 5 B's. Okay. So now let's just do the same. I'm going to map it, reduce by key, and collect all in one line. So people like Scala for this reason. It's functional programming, it's quite clear what's happening. So I just put those 3 steps in one line. Okay, so here's a little you try. So you try evaluating sort by key, right, which we haven't done yet, which will make a new RDD that consists of the elements of the original pair RDD that are sorted by the keys. Okay, so Spark kind of, I think it's still the best. So there's a sorting record, right? So it did the terabyte sort faster than any other system and stuff like this. So sorting is super elementary. Again, mathematically, it's very elementary. It's the core thing behind simulation. And so the more you sort, the better. The faster you can sort more, the better. So here I'm basically going to map each string to string comma 1, and that's going to be my pair RDD. And what I'm going to simply say is sort by key. Just call that method on it. So A is in lexicographic order, smaller than B in English. So this should be A5, B6. End of it. So now I'm collecting it. Okay. So sorry, A1, and so on. So I'm not sorting by key on the result of the reduce by key. So this is so the next key value transformation we will see is the group by key. This is generally to be avoided, but it's an important transformation you want to have in the back of your head because you cannot escape it sometimes. Okay. So so what is happening here? We're going to, let's look at the picture, read the words later. So we have A, B like this. Unlike reduce by key, in group by key, what's going to happen is, you know, things that are, you know, that have the same key get grouped, right? So, and then in the end, you know, you can do something like this. But generally, it's going to start accruing all the objects that have the same key together. Okay, so which means it can kind of get out of control fast. So, right. So here's an example. We have a word count pair RDD group by key. So I take my word count pair RDD and do this. Now it's you know, if you look at it, it's an RDD of string iterable int because that's like a container, right? So it's going to keep growing that thing. So now let me collect it to see what's really in there. So you can see that A, the key A, has been like accrued, grouped all the values, the same key, into some compact buffer, which is a Scala collection. And B, again, has another compact buffer of ones, right? So you have to be very careful with group by key. It will cause a lot of shuffling in the network. So lots of data can go, you know, from one partition to another, one node to another, because it's trying to group everything. And so generally you want, let's see, is go to clusters and, you know, Spark UI. Let's see all the stuff we've been just putting, you know, coding. Where is all of this? So here's quite a lot of information. So we have done, we will get into all these things in more detail later, but essentially there are Spark jobs, 37 jobs that have been completed. Here's a event timeline, you know, there's quite a lot going on. You know, what succeeded, what failed, what's running, and so jobs are divided into stages, and you can look at executors. Okay, so I have one active 6 RDD blocks. So there's a lot of information about shuffle read, shuffle write. We will make more sense of this later, okay? But I kind of just want to show you that this is a very nice thing with Apache Spark. So you don't need Databricks for the UI. You can run it on your local stuff as well. So it has quite a lot of details on, you know, what the environment is. We can also get this with the shell command. What is your path to Java home? What's the Java version, Scala version? Lots of things. And the more delicate things like rollover interval seconds and active frame size and blah, blah, blah.
In principle, you can understand which nodes are being allocated for a job. However, it's as far as I know, there is no way to predict which particular nodes will be used before you start the job. You cannot sort of target some nodes and run computation specifically on them. So all this is being figured out by cluster manager.
Yeah, exactly. So most of the time, what you'll be doing is trying to code in a way that you know, that is, you know, that doesn't expect your data to be in a certain order, because you have to sort, and if you want it in order, and that's expensive and so on. but a lot of the stuff we'll be writing, we won't need the data to be in any specific order, if you're careful. Okay, so we'll come back to this later. And driver logs, again, more details. And so it sort of gives you a lot more details, so you can chase things down later. So let me go back to something a bit more exciting. Let's see. So we just did RDD homework. I'm going to let you guys do this on your own. You need to really read things and slowly. So I've given you more transformations and actions like take ordered, and there's mostly just read it and make sure you understand it. More examples of reduce. I'm also giving you a little crash course here and there on Scala limits, like you cannot multiply doubles together beyond a certain point. You need to know the limits of your number screen and things like this. But yeah, so they're not just silly examples. There's actually some things you can learn from it. Flat maps and so on. Okay, so this is not assigned homework, but if you do this, then the assigned homework will be easier to do. But so let's now do this. This is the open link in a, copy link address. Okay, so there is a little bit of setup for this. Okay, so what we need to do is, remember we already did this do now. So you have this DBC archive, right? So let's go there first, which is in my workspace, Scalable Data Science, extra resources, okay, and SDS datasets, and scraper US State of the Union addresses. Okay. Because what we're going to do is make sure you have this data in your distributed file store in your community edition. Okay. And so this is some ETL operations that uses some bash and links and so on, and log sed and stream editors and tails and heads. And we don't need to understand all this, but it's all there. It's already been done, and you can just copy paste this on your own terminal later if you want to do it. So what we need to do though is I put the stuff, I bundled it up and put it in my sort of home area in GoDaddy. So we're going to just wget, fetch it, and put it here. That's what we're going to do now. So so first let's do this. %sh is shell, pwd is print working directory, and list, and give me a disk usage in a summarized human readable form of the current directory. Okay, just to make sure like we know where we are. Print working directory is Databricks driver, right? And ls tells me, oh, these are the files here. So you see, I already have sou.tgz. You guys won't have that, right? Because you haven't downloaded it yet. So anyway, what we want to do is, I think I made a bug here. So, so you want to run this command, Control X. Right, I just put it in the same cell. So I'm using this program called wget, and this is just my, oh, right. Yeah, sorry, this won't work, so never mind.
Why?
Well, it may, but let's see. There's a different one. Yeah, sorry, because that's from 2016 before Trump gave a speech. So let's just go here. So if you do this, I'm just wgetting a README file. Okay, so just, and I'm catting the README, so concatenate. So I'm just reading, I'm fetching this README file and reading it. Okay, so you guys should be able to do this. Yeah. So this is just what's in the README file and what was actually done. Okay. And so I just did this morning this Atlantis redo. So I just redid with Trump's State of the Union because the database I scraped from, is updated. So it's been a year. So this is what you want to run. So now I'm getting this sou.tgz file. TGZ is tar GNU zip format, compressed text. And now I just fetched that from lamaspec.org. Okay, so it should have downloaded and all good. Okay, so it's not that big, so that should happen quickly. Now let's hit ls and see what's there. So I have sou.tgz and tgz.1 because I already had it. You should just have this guy. Okay, sou.tgz. So now this is just in case you're paranoid. You can do %h and what are the environmental variables set on your Unix machine. It's not relevant for this, but so now I'm doing this, tar zxdf, right? Okay, I don't want to sound like, oh God, right? I just remember all this. I don't, all the time I forget. I just did it this morning, so I remember. So if you do man tar and you read the man pages for tar, then you will start seeing that, there is tar has this option, lots of options, and, and zxf is z is compressed extract, v is verbose, and file target is this. So that's all I'm doing here. So it will now create, so I know there's a directory called SOU. It created for me because I extracted it, right? So there's SOU now. So now I'm just CDing into SOU, right? This part just CDs into it. So I drop into that directory, change directory, and I'm just saying, and show me what's in there. So here are all the files from 1790, January 8th. So I guess when the Brits were driven out by George Washington, right, by essentially paying the lands of the Native Americans when they won the war, right? I mean, people's history of the United States, right? Howard Zinn. So that's the birth of America. So now you can find the head of SOU 1790-0108.txt. So that's the file, right? So now it says George Washington, January 8, 1790. Fellow citizens of the Senate and House of Representatives, I embrace with great satisfaction the opportunity with which now presents itself of congratulating you on the, it's very different from Trump's speech, you will see. Okay, you can read it. Actually, it's quite worthwhile reading it if you're bored. Red wine, warm tub, just read the State of the Union addresses. Tail just gives me the last part of it, right? Just to make sure everything is okay, there's no parsing error, and blah, 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 all that magic we did is sensible. Okay, so then you can just get Obama's thing if you want to see what Obama said in 2015. And I think when I did the database last year, that was the last one. This is just the tail of Obama's stuff. And here, I'm just looking at Trump's speech, where there's like definitions that will be introduced in Oxford English Dictionary on alternative facts and alternative truths and things like this. It's an interesting period, right? So anyway, this is Trump, and that's the tail of Trump. Tail of the text file of the State of the Union address of Trump. Okay, the tail of Trump. Okay, so now what is important is this. So I want to do a display db-utils.fs.ls. So this gives me, what's in my file store. What is my dbfs directory structure like? So, so there is something called Databricks datasets, Databricks results, and I put my own directories here, so you'll have a slightly different structure. So you have to answer some questions like, if you do this, do you see anything? Do you have a date? So this means it'll list a directory called dbfs datasets. Do you have this in your community edition? No, you don't. Okay. So then that's okay. Then we'll have to make, so then what you have to do is this, dbutils, dbutilities.fs.mkdirs, make directories, right? And then put dbfs : datasets.
Is there any way how I can pass parameters to make directory? Or just
just put the string right now, because we have only 3 minutes. I just at least want you guys to load it. I mean, I'm just creating a directory, right? So if I do datasets 0, this should create a directory for me called datasets 0. It should return a Boolean true, but don't do you do datasets without the 0, right? Because I already have it. Okay. So once you've created a directory, and if you do this, it'll be there'll be an empty directory for you. Just one way. Okay. You can skip this. I just removed it to just test it. You can recursively remove directories, but let's not worry about it. So you can do this, make directory SOU. I'm just showing you in steps, but you could have done this directly. So now let's evaluate this command. So you're creating a directory called SOU inside the datasets directory. Okay, so this should return Boolean true. And then, okay, so you should. So now, so we know where we are. We haven't gone anywhere different. So if you want to find out how I know these commands, so if you do dbutilsfs.help, it'll just tell you the basic things, right? Copying, head, ls, make, dirs, move, put, remove, and so on. So that's all you need. Mounting, we'll get to this if we want to mount directories from AWS and things like this. Okay, so now I'm doing this. This you want to do. dbutils copy. So copy, this should be where we extracted all the State of the Union text files into. And then this should just work if you did the right make dirs. I'm recursively copying the contents of this directory, which is in the local driver, right? That AW got.
On your laptop?
No, the driver in Databricks Community Edition.
Okay.
Because I got there, right? I did WGET on, or you should have done it. Okay, so once you evaluate this command, it should return a true. Then this is sort of the main test. So if you do display dbutilsfsls, you should see all these files there. So is everyone here? No? No? Okay. Because, then we can continue the actual thing next. Do you need help?
Is it
No, it's just.
Oh.
Yeah.
Oh, yeah, okay. Sorry, that'll take time.
Yeah.
Okay, sorry, because it's actually it's not the best way to show you how to load into a distributed file store, because there's something called a small files problem in Hadoop. It will take about 1 minute, 40 seconds. Okay, so yeah. But I thought, why not? Let's just do this so you can just load other things. So let's see. And these things will work later. So you can, once it's loaded, you should be able to do SCOtextfile, which is a method to read text file. And I can just say give the path once it's loaded. So don't evaluate it if yours hasn't loaded. And then I can do take 5. So now it's giving me an array of strings where each string is a line in the file. So remember George Washington white space was the first line, and the empty end of line character is just an empty string, and so on, right? Fellow citizens. So I have each line as an array because I'm taking an action, just the top 5. And I can collect. This is not a good thing to do, but we know the file is small, so we can collect safely, okay? Because it's,
Rasa, was it necessary to import file from distributed storage? Couldn't you do it?
No, I could have done it, but I'm doing it because I can just do the same exact thing for Wikipedia. Not with wget, but something more clever we'll do later. Yeah, exactly. So take ordered, well, just takes you, ordered, which is good. And this is very useful. The whole text files method is very nice because now it'll have a key, a key value pair, string. The first thing will be the name of the file, the path to the file, and the second element of the key value pair is the file itself, the contents of the file. So it's very powerful when you work with lots and lots of files, okay? Because now you have an RDD that's, and I count just to see how many of these are there. So there should be 231, because that's 231 State of the Union addresses. That's the duration. And there's a couple missing for some historical reasons. So, okay. And of course, it will take longer time than on your laptop, because this is a bad example of showing the power of Spark, because the files are too small. Okay, so that should be it. So once you've done this, I will stop today because I'm happy to have. So let's see. This is what we will continue tomorrow, right? So it's a State of the Union address thing, and if you are so inclined, you can read this PNAS paper. So that's where I kind of got this idea. So they're doing some interesting analysis of the State of the Union addresses, some natural language processing, digital humanities type stuff, or lexical shifts. And so if you're interested in this kind of stuff with text, I'm really game, like I'm into digital humanities. And there are data sets already here for this. And here's, you can read about this. Let me give you a very quick, so we will investigate this data ourselves, just the beginning part, the next meeting. But I want to give you a quick ad for this. If there's anyone interested in this kind of stuff, there is an interesting opportunity because we just won. We have a little group of mathematicians and theologists here in Uppsala that are interested in the meme evolution program. We're interested in mapping the sort of spread of extremist ideologies in social media. So we just got a nice cloud computing grant, which will allow us to actually capture about 1% of all of the global tweets that are hate-related and store it, and we can process as well. So if anyone's interested, and if you want to sort of, there's Matteo Magnani's group, I'm giving a talk about this. So if you're interested in that type of stuff, there's a group meeting you can come to. And this is very briefly about the meme evolution program. So a lot of this is actually an extension of Apache Spark, and it's all Databricks notebook based. So we formalize notions called tweet transmission trees, and so this is supported by Databricks and also a lot of probability from France and so on. And it's kind of a fun thing. So a concrete output of this could be like the population ideological tree for all of Sweden, right? Concrete target. How close are you in the ideological space of number of retweets, minimal number of retweets to some extremist, say maybe a Swedish jihadist or a Swedish fascist of a certain persuasion, or a transatlantic connection to specific black separatists, and I don't know, all kinds of. So we're trying to basically map out an entire atlas and taxonomy, and so one can actually just eventually say, where am I? Where are du? Where are jag? Right? How do I say it? Var jag? Var är jag? Where are jag? Right? It's really cool. Then I say, today, and then you can see the sizes of the clades, like this way population clades. Oh, now like I don't know, this kind of fascists are actually only 0.83%, and you can see that dynamically change, right? Because we're coupling it to the background discussions by MPs, members of parliaments, and politicians and blogs. All that code is kind of there if you want to play. All right, I'll shut up now. Yeah, sorry about the starting trouble, guys. So I'll let you watch those videos, okay, if you want, and then we'll continue from here.